I have also told you which two books are, uh, I mean, they can be useful throughout your engineering course as such. So the second and the fourth reference book, these two books are very nice. There is one more book. Uh, the author of this book is F.L. Singer. F.L. Singer. So this book, it is, I mean, the oldest book you can say, and it forms the base of all engineering mechanics, other books. Okay, so that book, even if you get, you can refer that book. That is a very nice book. The title is Engineering Mechanics by F.L. F.L. Singer. That is the name of the author. Next. Wait a minute. There is some problem. Yes. I had discussed about the two terms, majorly the definition of engineering. I have also discussed various fields of engineering like civil engineering, electrical engineering, computer engineering, mechanical, biomedical, etc. I have also discussed about the definition of mechanics. Combining together, we have defined the engineering mechanics course or engineering mechanics definition we have seen. And in this definition, if you read, it is nothing but the application of basic knowledge, which covers engineering aspect to study the state of rest or motion of the bodies subjected to action of force. This deals with the mechanics. So basic knowledge application and study of the state of rest or motion of bodies, those are subjected to different actions of different forces. Those that comes under the category of the definition of mechanics. So this is how the engineering mechanics definition comprise of, and in this it is very interesting to note that this engineering mechanics course shall not be restricted to only civil engineers, but it is applicable to all the engineering fraternity, irrespective of the field. Because in some or the other way, this parameter, that is the state of rest or motion of the bodies subjected to forces, all these terms are involved in engineering. So there is no escape. One has to learn this engineering mechanics course, and it should form the base of the engineering course. So likewise, we also saw what are the different engineering mechanics and what subjects or what courses or rather what topics we shall be covering in our complete engineering course. I am very much concerned about civil engineering, so I will be now discussing about the civil engineering topics. So firstly, in our course, we will be dealing with this rigid body mechanics. We have also seen what this rigid body is all about, isn't it? So rigid body is something which uh, doesn't undergo any kind of deformation, or the deformation is very, very negligible or very less compared to the overall size of the body whenever some external force is applied onto that. Also, there is no change in the shape and the volume of that body. In that case, we term it as the rigid body. In that rigid body mechanics, we have two subtopics. First topic deals with the statics, another deals with the dynamics. This will be in our course. Later on, in your higher courses, you will come across the deformable body mechanics, that is strength of material you will be dealing right now, theory of elasticity, theory of plasticity, these two parts, these are actually, especially the theory of elasticity. This is a complete separate unit in MTech structural engineering. Theory of plasticity is dealt in steel structure and RCC structures. So somewhere the introduction of this theory of plasticity can be seen in these two topics, but this is a vast topic altogether, right? So in engineering courses, you will deal with the basic aspects of all these parameters. Next, fluid mechanics. So in the next semester onwards, fluid mechanics will be taught to you, and you will come across all these aspects. So fine. So this is what is about the engineering mechanics as a whole, and these are the subtopics which you will be studying now and in your further semesters. So we have seen rigid body. We saw the discussion related to the statics, dynamics, and whatever discussion I had done yesterday, that was very superficial type of thing. Now let us try to go into the details of these things. Statics, as the term suggests, that the body, and keep in mind, from now onwards, the discussion will be related to rigid bodies. Okay? So the bodies, whatever I will be repeating all the time, those bodies will be necessarily the rigid bodies only, right? So whatever discussion I will be doing right now from this point onwards, that will be related to the rigid bodies only. So in case of statics, whenever a body is steady, okay, whenever that body is not moving, it is steady, we call that condition to be static condition. It doesn't move, okay, it is motionless. Sometimes it is also known as equilibrium, but whenever we whenever we call this equilibrium term, then this equilibrium needs to be defined. That definition and all we will be discussing in the further part of our discussion. So statics is nothing but a part of equilibrium. Dynamics, it consists of two subparts, kinetics and kinematics. Kinetics is nothing but that study of the bodies which are in motion whenever we consider the forces causing the motion of those rigid bodies. That part of study is known as kinetics. Whereas in kinematics, again, it is a study of the bodies, those are in motion, but we do not consider the cause of the motion. Okay, we study just the geometry, and based on that geometry, whatever may be the final aspect or parameter which we need to find out, that is been calculated. जैसे मैंने कल एक एग्जांपल दिया आपको कि if you kick a ball and that ball final position is to be found out, then we do not consider the force at which that kick has been applied. No, what we consider the trajectory which that ball may follow. Okay, so based on the equations of that projectile motion, then we consider the or we find out the final position of that ball. Okay, so this comes under the study of kinematics, and I hope in your 12th standards you must have dealt with the numerical related to kinematics, if I am not wrong.
Yes, sir.
Okay, fine, right. So this may form just a revision of your 12th standard basics, nothing more than that. But in kinetics, have you gone through the numerical related to bodies which are in motion, wherein you must have used the virtual work concept or dynamic equilibrium equation? Have you gone through such type of things?
No, sir.
Okay, so we will be dealing that part thoroughly in this course, right? And a very what you can say basic discussion related to kinematics will be done. Now let us discuss about the statics. Okay, so as a definition says that the bodies may either be at rest or move with a constant velocity. That rigid body is known as uh, static rigid body. Okay, or the study related to such kind of rigid bodies, those are either at rest or they move with a constant velocity. In the sense, there is no disturbance in that rigid body. It is constantly moving with a very constant speed. There is no disturbance. So such cases are also treated as static cases, and that rigid body will be in static. So you can see there are few examples which I have shown over here. A person which is sitting on a chair, uh, it is a static case, there is no movement. Then this is a vehicle which is again moving with a constant velocity, which is denoted by V, right? And there are few arrows which are shown over here. All these things I will be discussing in depth in the coming lectures. But just try to understand the various examples of statics. Then this third example is of a crane which is carrying some load. It is in a steady state or it is in static case, right? So these are few examples, and the application of this, see, I have shown the figures, but the application of these figures somewhere you will find in the further discussion also. I will be discussing that thing. Okay, so this is a part of static, and then the dynamics, the thing which I was discussing about. This vehicle, this will be uh, this will be moving with the help of some acceleration which is provided to that vehicle, and this will deal with the kinetics part. So that discussion will be done, and similarly for kinematics you can see this example which I had quoted earlier. So these are a few examples related to dynamics. Dynamics, it deals with the accelerated motions. Okay, so there in that case you will find that there is variation in the acceleration, variation in the velocity. The velocity may not be constant. Had that been constant, then we would have considered it into a static case. So like that. In case of dynamics, there is change in the motion of the rigid body, which you can expect in case of a car. There may be a kind of speed breaker over here, and because of which the velocity may vary. Okay, so like that. Fine. So before going into the depth of the rigid body mechanics, we should consider a few fundamental concepts, and these are all known to you, but I will again revise this. Length in a space, and a length which is measured in a space. Actually, it is required to locate the position of a point in any space, and it describes the size of the physical system, that is distance, geometric properties, etc. So that the length is measured in meter, centimeter, likewise. Then second fundamental concept which we need to consider is of time. Time is nothing but measure of succession of events, basic quantities. Those are required especially in dynamics, because static has no role. I mean, static study doesn't require any time concept. It is steady. It doesn't move. So there is no requirement of any time, right? So time is a measure of succession of events which is required in dynamic study. Then mass, it is nothing but quantity of matter in a body. That is basically, it is a measure of inertia of a body. That is its resistance to change in velocity. And finally, most important parameter is of Force. It represents the action of one body on another characterized by its magnitude, direction of its line of action, okay? Its line of action and its point of application. These two parameters are very important for rigid body study. We will see that. Okay? I have changed the color of these things. Line of action and point of application. Force is a vector quantity. So we will see what are these things. Next concept is of magnitude. Magnitude is nothing but the amount of force which is acting on the body and is characterized by units, different units like kilonewton, newton, meganewton, giganewton, etc. And then direction. See, since force is associated with magnitude as well as direction, we need to consider in which direction the force is getting applied. Okay, so we should know what should be the direction. So there are few, what you can say, thumb rule type of things which we need to consider, or we call it as the fundamental concept. And for especially for force, we should know the exact direction of the force that is being applied. So direction is defined by the angle its line of action forms with a fixed axis. So there again, line of action word, this statement has arrived. Line of action. So what is this line of action? Okay, let us first of all understand the term line of action of force. Now see, this is a figure which represents a certain force whose magnitude is represented by capital P. Okay, so this capital P stands for the magnitude. Magnitude of this force which is applied in the horizontal direction, true horizontal direction, it is getting applied at this point capital A of this rigid body. Okay, this is what we consider initially. Now if I want to see the effect of this force which is applied at this point A on this rigid body, at some point, let's say over here, then what I will do, I will extend this force line, which is also known as the line of action of the force whose magnitude is capital P, in the direction of application of the force. So what is the direction of application of the force? It is horizontal. Correct? So if the direction of application of the force is horizontal, then if we extend that direction of application of the force, that thing is known as line of action of the force. So not necessarily this force will always be horizontal. It may be inclined also. So if you want to assume that case wherein some inclined force is getting applied, you can see this example. Are you able to see this example? Can you see this?
Yes, sir.
So what do you notice over here? There is some connection with respect to some bar. This is a bar, you can say. Okay. And this bar, if suppose it gets pulled, let's say for example, it gets pulled by some force. So don't you feel that the direction of this force will be inclined with respect to the horizontal? Don't you feel so?
Yes, sir.
So there are some more cases. For example, let's say, have you seen the Ram Jhula? All of you must have seen the Ram Jhula in Nagpur. near the railway
Yes,
station.
sir, near railway station.
Yes, so that Ramjula is nothing but a cable stayed type of bridge structure, isn't it? So in that cable stayed bridge, you must have observed that there are various cables. Those are attached in inclined positions, isn't it? Or the purpose of these such type of bridges, wherein cables are provided, the purpose is to carry tension force which will be transmitted on the bridge through these cables. So in short, these cables will carry tension force in them. Okay? So these forces, if you try to visualize, these forces will be inclined forces because the position is nothing but inclined, right? So the forces not necessarily will be always horizontal or not necessarily truly vertical. They may be even inclined. So you can visualize such kind of inclined forces also. But if we consider the direction of the force, and if we try to extend that direction of the force, that extension of direction of force is nothing but the line of action of the force. I hope you have understood this term, line of action of the
Yes,
force.
sir.
Okay. So likewise, we should know the direction, and there are few sign conventions which you need to remember because we will be uh, starting with some numerical examples wherein this information will be very much important. तो ये साइन कन्वेंशन जो अब मैं बता रहा हूँ that you are supposed to memorize. This reference will be there for you, but just try to understand. It is very easy. In order to understand the sign convention for forces and the direction related to the forces, we should first of all consider the axis. This is the vertical axis, and this is horizontal axis. So you can consider this to be x axis and y axis, not axis, x axis and y axis. Okay. So once we define the axis system, then if the force is acting like this, okay, direction which is on the right side of this axis, vertical axis, or in the parallel to the right x-axis, it is known as right of x. So you can see this force which is pointing towards right of x, it will be called as the direction which is right of x-axis. Similarly, if it is pointing like this, how it is pointing? It is pointing parallel to the x-axis, but the direction is on the left side. So this is the neutral location, you can say, the intersection of the x and y axis, which is 0 point. So if such kind of direction is observed for a force, so it is nothing but left of x-axis. On the same line, if I want to represent in terms of statement that how this force is acting, this force is acting upwards or in the up direction of y-axis. Similarly, how this force will act? This force will act in the downward direction or down of y-axis. Got it? So these are few sign conventions related to the force which is truly horizontal and truly vertical. So you can see this is the horizontal force, this is the vertical force. Now, as I have told you that there are certain cases wherein the forces may be inclined, right? So inclination may be in any direction. ऐसा जरूरी नहीं है कि वो एक ही direction में हो. Inclination may be in any side or any direction. So let's say if the inclination is like this, okay, and with respect to the x-axis, the inclination angle is, let's say, 30 degree. Magnitude of this force which is acting from this point at an angle of 30 degree is, let's say, 30 Newton. So how to describe this force? This force of 30 Newton is acting up to the right at an angle of 30 degree with x-axis. So you can say, you can see this face, this complete face of this axis system. This comprise of the right direction, isn't it? Right side. So that's why force of 30 Newton acts at right, acts up to the right at an angle of 30 degree with respect to the x-axis. Fine. Similarly, if it is acting in such a way, the same example, for the same example, if it is acting in such a direction at an angle of 45 degree, and if let's say the magnitude is 50 Newton. So how will you describe it? Force of 50 Newton acting down to the left at an angle of 45 degree with x-axis. ठीक है? Is this okay?
Yes, sir.
Sir, to the right होगा ना?
What it should be?
To the right.
Right,
To
sir.
the right, है ना? तो यहाँ पे correction है. It should be right at an angle of 45 degree with x-axis.
X-axis.
ठीक है? Great, good. Then, if you have understood this sign convention, now let us see. Let us say that in order to study engineering mechanics, there are few assumptions which are to be considered. These assumptions are made in order to simplify the complex problems which we may come across. देखो, सबसे पहला जो assumption है, that is of the rigid body. As I have told you that rigid body is a hypothetical concept. There are no such bodies which may not undergo any kind of deformation. The only thing is that we are not in a position to see them with the help of naked eye, isn't it? So likewise, but see, if you compare the body, complete volume of that rigid body in comparison to that volume or the size or the shape, if the deformation is not seen, it is negligible, then we can assume it to be perfectly rigid. Perfect rigid ऐसा कोई system नहीं है. So see, likewise, we are supposed to consider few more assumptions. So there are few assumptions which we need to remember. First is of particle. What is that? A body with mass, but with certain dimensions, which can, the dimensions can be neglected. Like for example, size of the earth is insignificant compared to the size of the orbit that you all know, right? So earth can be considered as a particle in the orbital system. So earth can be modeled as a particle when studying its orbital motion. It is justified. There is no harm, right? Similarly, rigid body, that is an again assumption. It is combination of large number of particles. So another definition of rigid body, if you read this, it is combination of large number of particles in which all particles remain at a fixed distance from one another before and after applying a load. ठीक है? तो जो particles जो है वो disturb नहीं हो रहे, even if we apply the external force. Okay, so this is a practical definition which we can assume. So I have also mentioned a note that in most cases, actual deformations occurring in structures, machines, mechanisms are relatively small, and rigid body assumption is suitable for such type of analysis, and that's what we will be following. this case, and it is very judicious to consider such kind of assumption, we get a logical solution out of this that we will see. Next, there are different types of forces. One force which I would like to discuss at this point itself is, it is known as the concentrated type of force, or sometimes it is also known as point load. तो ये जो मैंने रिप्रेजेंट किए थे, ये जो लोड्स है या फोर्सेस, what I have shown over here, what did I show over here? I have shown point or arrows. Okay, such kind of forces which are represented with the help of arrows, these are known as point loads or concentrated loads or concentrated force. What are they? The effect of load which is assumed to be acting at a point, which is basically the CG or center of gravity on a body. That force is assumed to be acting. It is assumed to be acting as a arrow, and that arrow, as in I have shown you earlier, that thing is known as the concentrated force. Okay, provided the area over which the load is applied is very small compared to the overall size of the body. If this case is satisfied, that is what is the case. If the area over which the load is applied is very small compared to the overall size of the body, then we term that force to be a concentrated force. So let's say, for example, this vehicle. For this vehicle, if I want to transfer the load which is coming from the top body of that vehicle through these tires or through these wheels, such kind of forces are represented with the help of an arrow, and those forces which will be transferred on the surface on which this vehicle is moving, that will be treated as a concentrated force. I will tell you the reason. देखो, vehicle जो है वो कौन से surface पे move होती है? Mostly the earth surface, isn't it? And that earth surface, if you visualize earth surface, is kind of infinite, although we know the dimension of the earth. But for this vehicle, what is the size of the earth? It is very much large. Okay, so whatever force will be transferred from this vehicle to the surface, that is the earth surface, what do you see? The forces are acting in the acting as concentrated force, or we can treat them as concentrated force. ठीक है? Second example, this is very interesting example. अब इसमें आपको कौन से concentrated load दिखाई दे रहे? Can anyone tell me? This is one picture which I have shown. In this, which loads or which forces can you treat to be concentrated load or concentrated force?
So legs
So
of
the
chairs
fan
and table.
suspended.
Yes. One by one.
So legs of table and chair.
Legs of table and chair. Okay, very good.
We
Anything else?
suspended fans.
Excellent. Suspended fans. Very good. Excellent. So you have understood the concept of concentrated load or concentrated force. Excellent. So both the examples are very correct. The forces which will be, represented by the legs of the chair and fan. Excellent. Good. So this is the example of concentrated force. Next, few more assumptions. This assumption is basically known as the axioms of mechanics, which comprise of the Newton's law. I have described all these laws with respect to the particle, but you can apply this to the rigid body also. If we collect the small particles together, they will form a rigid body, and the whatever laws Newton has laid, all those will be applicable for the rigid body also. So you all know first law: particle or rigid body originally at rest or moving in straight line with constant velocity tends to remain in this state provided the particle is not subjected to external unbalanced force that is known to you. That stage is known as equilibrium. So whenever you come across this term of equilibrium, it is a part of static, undoubtedly. But if you want to define equilibrium, then you are supposed to say that the rigid body, which is at rest or moving in a straight line with a constant velocity, tends to remain in the state provided the particle is not subjected to unbalanced force. So while defining equilibrium, we should take care of the forces also. Okay. So this state of the particle or the rigid body is known as equilibrium state.
Sir,
Yes.
sir, what does the diagram represent?
What?
A particle moving in a straight line?
Yes. Now see, there are two things. First thing is all these forces which are acting. Can you see the direction of these forces?
Yes, sir.
How are these directions? They are
Towards the particle.
towards the particle. That means all these forces are trying to move the particle in one direction,
No, sir, different directions.
different direction. But what will be the final this thing output?
You will cancel out.
Resultant will be zero, sir.
Yes, yes. Resultant of all these forces will be zero. That is what is the final conclusion. Summation of all the forces which are acting on that particle, or in our case, it will be a rigid body. If it is zero, then we say it to be in static or equilibrium. Or in other word, if the velocity with which this particle or rigid body moves, if it is constant, then the net effect on this particle or rigid body will be zero. Or in other term, it will be in equilibrium. Got it?
Yes, sir.
Right. Then the second law: a particle or rigid body of mass m acted upon by unbalanced force F experiences an acceleration, let's say small a, that has the same direction as the force and magnitude that is directly proportional to the force. Force is equal to mass into acceleration, and it forms the basis of the dynamics. So we will see the application of the second law when we will deal with the dynamics part. Okay. So first law, statics; second law, dynamics; and the third law, as you can see, mutual forces of action and reaction between two particles are equal, opposite, and collinear. Okay. Collinear means lying in one line. So the third law is basic of our understanding to force, what exactly force is all about. Okay. Another axiom which comprise of the weight. You all know the concept of the weight, no need to describe it, which is nothing but the Newton's law of gravitational attraction. Okay, so this is another axiom. Then the description related to the that particular axiom. This is just a concept which you have already learned. Now this is the important concept, which is of the principle of transmissibility. Okay, what it states, just try to understand. I will read out the definition. This states that the external effect of a force on a rigid body is same for all the points of applications along its line of action. external effect of a force on a rigid body. So let me consider this rigid body. This is the same example which I had explained you for the line of action of force. So this is a rigid body, and if some external force is applied, let's say P, this force is applied in this direction, horizontal direction at this point A. This point A is known as point of application of force at point A. Okay, point of application A, right? The effect of the force, whatever force you are applying at point A, that will be same along this line of action of the force at a point, at another point, let's say this point, with the same magnitude, right? So rigid body concept is such, as we have found or discussed in the earlier slide. In that you must have seen the definition, modified definition of rigid body, wherein the particles, they are conglomerated at a specific distance without, I mean, without disturbing the particles position. Whatever force is getting applied on that rigid body, it will have no effect, or the deformation is not observed. Based on that assumption, what we consider is that whatever force that is getting applied at one point of the rigid body, the same magnitude will be transversed along the line of action of the force, that is this, at some another point, let's say this point B, without disturbing the deformation, without disturbing the shape of that rigid body. So in order to understand this example, you can see this figure. So what do you observe over here? Let's say force of magnitude capital F is applied in order to move this vehicle. Okay. So that point of application is somewhere at the front part of the vehicle. If we extend this line of action of force, whatever I have shown you, then the same magnitude of force shall be applied or applicable at the rear part of the vehicle. Okay, and this magnitude won't change. So that is nothing but the principle of transmissibility, right? So that this principle of transmissibility will be used every now and then whenever we solve the numerical related to rigid body. Okay, we will see the application of this once we solve some examples. Then you will come to know what exactly this is all about. But for time being, just try to understand that whatever force that is getting applied at one point, it will be transferred at the same magnitude along the line of action of the force throughout the rigid body. Okay, got it?
Yes, sir.
Sir,
Yes.
sir, can we compare this concept with collision concept?
Collision concept, in that what do you observe? That
Momentum, sir.
two rigid bodies, they what you can say, collide each other, and
Yes.
after collision they get separated.
Yes, sir.
They get separated, isn't it? And they move in direction. Now see, that it is interesting to note over here that the application of the force will not be the same after collision. It will depend upon the direction of the force which is getting applied. मान के चलो, the direction, if the direction of the force is inclined, it is not truly horizontal. In that case, you may not find that this principle of transmissibility is applicable. Firstly. Secondly, that case is applicable only when the collision is of specific type, that is collinear collision. Okay. In that case, you can say that yes, line of application of the force or principle of transmissibility may be applied. But that is a very specific case. It is not true for all the collision types.
Yes, sir.
Okay?
Yes, sir.
Yes. Okay, so there are few more parameters like scalars, vectors. ये आप लोगों को पता है. So these are a few terms which you also need to understand or keep in mind while considering engineering mechanics numericals. Okay, there are a few fundamental quantities like mass, length, time, force, and the units associated to them, units and the prefixes. Okay, so these are few terms which you need to keep in mind. I think all of you are very well versed with all these symbols, okay, and prefixes also. Okay, so what we covered, we have covered up till now the fundamental concepts, few assumptions, the axioms of mechanics, which covers the Newton's law, the gravitational law, and the principle of transmissibility, right? One more concept, that is of scalar and vector, which comprise of the parallelogram law that you all know. Okay, so all these cover the axioms of engineering mechanics, and we will see the application of these axioms in the coming lectures. Okay, so I will stop over here, and if you have any questions, queries, you can ask. Have you understood this thing up to this?
Yes, sir.
Yes, sir.
These are all basic things which I have just browsed, nothing else. So I hope it is understood to one and all, and I will stop over here. From the next lecture, we will see the further extension, that is the important things which are necessary for solving the numerical related to rigid body mechanics, and what are the different types of forces those are applied on the rigid bodies. Okay? So thank you very much. Yes.
Thank you, sir.
Yes. Any
Sir, can
question?
you share this slide?
Yes, definitely. I will be sharing this slide once I cover this numerical. As you can see over here, ये numerical एक बार खत्म हो जाए, तो मैं आपको ये slide पूरा share कर दूंगा.
Okay, sir.
ठीक है?
Okay, sir.
And I
Okay,
will be sharing this on the classroom itself.
Yes, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.